we are going to discuss some more questions related to composite functions. Now, question is already written. You just see a is equal to r minus 3 by 5 means real number except 3 by 5. B is a set which having real number except 7 by 5. That f is a function from a to b such that fx, the value of fx is 7x plus 4 by 5x minus 3, and g is also a function from b to a g, and such that g of y equal to 3y plus 4 by 5y minus 7. Prove that gof equal to ia means identity function, and fog is equal to ib. Now why it is a is given as real number except 3 by 5? Because f is a function from a to b. It is not defined when 3 by 5 will be take here. In case of denominator, if we take x equal to 3 by 5, then denominator become 0. Anything divided by 0 not defined. So that is why in this function fx, set a does not contain 3 by 5. And here also g of y equal to 3y plus 4, 5y minus 7. 7 by 5 if you substitute here, then it becomes 0. So that is why in A 3 by 5 is not present, in B 7 by 5 is not present, but these both are real numbers, so it is a real valued function. Now regarding IA, what it is? IA means, suppose A is a function, this is also A is a set, and the function which is, instead of f, if I write IA, that means in place of fg it is written ia. Only it is a notation. This notation indicate it is a function from I to I. And what is ia? If I take x, ia of x, it gives x. So whatever the input, if you take, output become same. If you take 1, then answer is 1. If you take 2, answer is 2. This is IA. And IA it is written means it is on set A. If IB is written, IB of x, IC of y. This is called identity function. Okay. Domain and codomain both are same, and images also same, means range all the three is same. And if you draw the graph of identity function, you know it is passing through the origin like this. This is the identity function, and it is always 1 1 and on 2, means it is invertible. Now in this question we have to prove ia equal to gof equal to ia and fog equal to ib. So let x belongs to a. If I take an x is an element of a, then gof of x means g fx. So g fx is what? 7x plus 4 by 5x minus 3. This is the value of fx. In place of x, y, it is written g of y is this much. So g of y means 7x plus 4 by 5x minus 3. So g of y, that is 3 into 7x plus 4, 5x minus 3 plus 4 divided by 5, 7x plus 4, 5x minus 3 minus 7. Now it is 21. 4 3 is 12 plus 20x minus 12. In case of LCM, in LCM both LCM will be cancelled here and here. So it is 35, 20 minus 35x minus plus 21. So this is 41x, cancel. This also cancel, 41. So this equal to x. Now this we can write IA of x. Why? Because IA of x, if I write, then answer is x. Why? Because x is belonging to A, and if x is belonging to A, you can write here for all x belongs to A. So IA of x. Now what happened? Gof of x equal to IA of x. So we can write gof equal to IA. So gof is IA. Now what about fog of fog is IV. Now let y belongs to B, then fog of y equal to f g of y. So f g of y means what? 3y plus 4 by 5y minus 7. This equal to fx. X means this. So in place of x I have to write 3y plus 4 by 5y minus 7. So 7 into 3y plus 4 by 5y minus 7 plus 4 divided by 5, 3y plus 4, 5y minus 7 minus 7, sorry, minus 3. So this equal to 21y, 28 plus 20y minus 28 divided by 15y, 20 minus 15y plus 21, 41y by 41. So this is y. So this we can write IB of y. Since IB of y equal to y for all y belongs to set B. So this is also identity function. So therefore fog of y equal to IB of y. So therefore fog equal to IB. So gof equal to IA and fog equal to IB. Now you write next question. Let f and g are two real function and such that f of x equal to mod x plus x and fx and gx mod x minus x for all x belongs to real number. Okay, find fog and gof. Both thing you have to find, fog and gof, and also find fog of minus 3, fog of minus 3 and fog of 5, and one more you can take, any number you can take, no issue. Fog of gof you find gof of 2, gof is not there. Okay, any doubt? Now see here, for first of all mod function is there. So mod x equal to minus x when x is less than 0, 0 when x is equal to 0, x when x is greater than 0. So this is the value of mod x. Mod x is never, if we take out from mod, then answer is always positive, means this is regardless of sign. We cannot take sign, means positive sign. So here mod x is also positive. Why? Because x, the value of x is negative and this negative, both negative become positive. This is positive x. So you don't think the output is negative. Here it is also positive, and here it is positive, and here it is 0 when x itself 0. So now we can combine the cases like this. X when x is greater than equal to 0, in that case you can take x minus x when x is only less than 0. So first fx, for fx when x is greater than equal to 0. What is the value of x? Mod x plus x. So now the x is 2x, x plus x 2x. So again fx when x is less than 0, fx equal to mod x is minus x plus x 0. So fx gives what? 2x or 0 when if x is greater than equal to 0, if x is less than 0. This is the value of fx. Now what about gx? For when x is greater than equal to 0, mod x is equal to plus x, then gx, g of x what? Mod x minus x. So x minus x gives 0. When x is less than 0, mod x gives minus x. So then g of x equal to minus x minus x. Then how much? Minus 2x. So altogether gx equal to 0 when x is greater than equal to 0, minus 2x when x is less than 0. So this is the value of only fx and gx. Now what we have to find? We have to find the value of fog. So fog. So you find fog x. So fog x, f g of x. So here two cases. When x greater than equal to 0, the g of x is how much when x is greater than equal to 0? Where it is gx? Here, greater than equal to 0. So f of 0 means what? F of 0, for 0 it is 2 into 0, so 0. Now when x less than 0, fog of x, f g of x, f g of x is how much? G of x when x is less than 0. When x is less than 0, what it is? Minus 2x. So here x is negative and the here x is minus x. So that means x, the value of x is positive there, this x. So we can write this as, where x is greater than 0, so it is 2 to the 4, minus 4x. So g of x is minus 4. If there is any confusion, just see. If I have to take any negative value, suppose this question minus 3. So if I take minus 3 here, so g of minus 3 means minus 3, that is plus 6. So because minus 2 into minus 3 I have to take now. So minus 3 to the plus 6, f of 6, or f of 6 if we take, so f of 6 will lies here, so the answer become 12. So you don't think it is minus means x is here, or entire thing is positive, because I taken negative. See again, f of, if I take minus 3 and here x is less than 0, So in this case f is g of minus 3. So g of minus 3 means what? G is negative. So g is negative means here minus 2x. So f is 3 to just 6x, and f of 6x when x is less than 0, but x is what? Greater than 0. So x is greater than 0, then answer is what? 2x. So 2x means 2 into 6, what it is? 12. Okay. So in this case, if it is negative, then answer is, for this question I given, the answer is 12. And next one more is there, fog of 5. Fog of 5, f g of 5. G of 5 means what? G of 5 means x is positive. Positive means 0. So f of 0. So f of 0 means what? 2 into 0, 0. Okay. Next, fog is there. Now, what is fog of x when x is greater than or equal to 0? So f, gof na, fog is over gof of x. So g f of x. So g f of x means what? fx is greater than 0. X is greater than 0, then it is 2x. And g is positive. G is positive here. X is greater than 0, so it is 0. Entire thing is 0. So gof of x, it is 0 when x is greater than 0. Next, one more point. Gof when x is less than 0. So gof of x. So g f of x. G fx is how much? Less than 0. So less than 0, that is 0. So g of 0 is 0. So in both the cases, gof is 0. So entire thing, just see. One more question is also there. Gof of 2. So gof of 2 is also 0. Now, regarding fog of x contain two answers. One is what it is. One is 0 when x is greater than or equal to 0, minus 4x when x is less than 0. And what about gof of x? 0 when x is greater than or equal to 0 or x is less than 0. In all the cases, gof is, therefore gof is equal to 0 for all x belongs to R. So this is the answer. Now, last topic, that is invertible function. So take that questions. First of all, what is invertible function? I already explained earlier classes. Invertible function means that function which is 1 1 on 2. The function which is 1 1 on 2, that is called bijective function, and bijective function is always invertible. So right, invertible function is what? Invertible function means what? The function which is 1 1 and on 2. Now let f is a function from a to b. F is a function from a to b if there exists exists a function g from b to a such that gof equal to ix, gof equal to ia, and fog equal to ib, then f is called invertible function, and it is denoted by and g is called the inverse of f, and we write f inverse equal to z. So this is your invertible function. Now here it is given a b a, this is f, this is g. So f is a function from a to b and b is a function, g is a function from b to a. So this is gof, gof is a function, gof means what? G circle f, G circle f means f composition g. So when we take x here, so this is g of, here we can take gof, gof equal to what it is, gof equal to ia. So gof equal to ia means what? How we can? Because if I take here x, then this is y equal to fx, and here if we take z, suppose z is there, so g of y, this is g of y, so z means gof of x, so gof of x means g f of x, and if g f of x, and f of x means what? F is a function a to a, so a to a, if gof, it is same answer will come, gof equal to that same x, so gof equal to ia. When it is coming, then the function is what it is, gof equal to ia. And next one more thing, now one more condition is there, gof equal to ia and fog equal to ib. So fog equal to ib means here g is a function from a to b to a, and this is b, a to b, again f, so this is what? Fog. So if fog equal to ib and gof equal to ia, then g is called the inverse of f, and it is denoted by f inverse equal to g. And other definition also I told, when f is 1 1 and onto, then f is invertible, f is invertible. So if I have to prove, if you have to find f is invertible, then I have to show the f is 1 1 and onto. Now some more questions. That means you have to prove bijective. If it is bijective, then function is invertible. So from this lot, one question we have to see, what is 1 1. How we already proved earlier what is one, how we can show it is 1 1 onto. First of all, 1 1 we have to prove 1 1 and then onto. So for this, you take one question. Write let R plus is the set of all positive real numbers. So R plus means what? It is a set of all positive real numbers. Then and f is a function from R plus 2 minus 5 to infinity, such that f of x equal to 9x square and plus 6x minus 5 is invertible, and find f inverse. The question is important, and just see how we can. R plus means we have to take only positive real number, and the answer will become minus 5 to infinity. See, for function for invertible, we have to show f is 1 1 and onto. This we have to show it is 1 1 and onto. Now how we can? For 1 1, the concept is never changed, it is always same. Earlier how we can prove 1 1? For 1 1 in from first set we have to take two distinct elements, and we have to say prove that two distinct element having two distinct images. So same thing, let x1 comma x2 belongs to R plus. Okay, and images you have to take it as equal. Images are equal. F of x1 equal to f of x2 implies this is 9x1 square plus 5x1 minus 5 as 6x1 minus 5 equal to 9x2 square plus 6x2 minus 5. Minus 5 cancel. So 9 if you take common, then x1 square minus x2 square plus 6 if you take common, then x1 minus x2 equal to 0. This implies now 3 and x1 minus x2 is common. Then here 3 3 is 9, x1 plus x2 plus 3 2 is 6 equal to 0. This is never 0. So x1 minus x2 is only 0. So this implies x1 equal to x2. So when f of x1 equal to f of x2, therefore f of x1 equal to f of x2 implies x1 equal to x2 for all x1 comma x2 belongs to R plus. So this is 1 1. So therefore f is 1 1. F is 1 1. Next point, we have to prove it is onto. For onto, what we have to do? We have to take one arbitrary element in second set. Let y belongs to minus infinity minus 5 to infinity. Let y equal to fx equal to, what is fx? 9x2 square plus 6x plus 5, and we know that we have to convert the value of x in terms of y. So write y minus make it as a perfect square. Y equal to 3. If you take common 3, then it is x square. How we can do this as a perfect square? See, y equal to 9 3x whole square, a square plus 2a and b means 1 plus 1 square minus 1 square plus 5. I think it is minus 5. So y, this is minus 6 plus 6 and 3x plus 1 whole square. This implies 3x plus 1 equal to root under y plus 6. So this implies 3x equal to root under y plus 6 minus 1. This implies x equal to root under y plus 6 minus 1 by 3. So this is the value of x. So for each y belongs to minus 5 to infinity, there exists a real number, positive real number. X belongs to minus 5 to r plus, such that f of x equal to y. So f of x is what? It is 9x. X means root under y plus 6 minus 1 by 3 square plus 6 into root under y plus 6 minus 1 by 3 and minus 5. So this is 9. This is y plus 6 square plus p square minus 2 root y plus 6 and by 9 cancel, plus 3 2 just 6, 2 root under y plus 6 minus 6 minus 5. So again solve it. This equal to y plus 6 as 7. This is 2, I think. Y plus 7 minus 2 root y plus 6 plus 2 root under y plus 6 minus 7. So this is y. So f of x equal to y means what? Range equal to codomain. If range equal to codomain, now therefore f is onto. So f is 1 1 and onto. That is f is bijective. So yeah, therefore f is invertible. Now we have to find f inverse. So very simple. Now how we can, for f inverse, let f of x equal to y. So this x is equal to f inverse y. So this implies f inverse y equal to x. X means how much? X means root under y plus 6 minus 1 by 3. So this is your inverse. You may change the variable. You can change this x, root under x plus 6 minus 1 by 3. In place of y, I written x. So now you define the function. F inverse is a function from, that is minus 5 to infinity 2 r plus, such that f inverse of x equal to root 6 plus root x plus 6 minus 1 by 3 for all x belongs to minus 5 to infinity. So this is the required answer, and I think I completed all the topic, means the function, under function, all the content I explained. So revise all the content and make a note, and then I already given assignment. That assignment also you solve, and next class we will start ITF, inverse trigonometric function. Okay, thank you.